Hello everyone, this is another video in which I am going to solve a problem count subarrays with some k. This is another variant of the problem which I have solved in my last video, and that we have to find the length of the longest subarray with the sum k. So we have checked the subarrays with the sum k, and then whatever the maximum length was there, that we have returned in the form of a max length variable. Now in this particular video, this problem is about counting the subarrays, whatever the subarrays which are giving the sum k. So we have to count those subarrays. Now the problem statement says that we are given with an integer array nums and an integer k, and we are this particular subarray is a contiguous part of the array, we all know, and we our task is to return the total number of subarrays whose sum is exactly equal to k. Those number of subarrays we have to return here. Now I have just explained the multiple approaches for the previous problem, like the brute force, then the prefix sum plus hashing approach also, and the sliding window approach. But here, see, brute force approach can be used here, like checking for all the possible subarrays and then counting if any of the subarrays having some key. So we can just keep the counter and then check for the number of subarrays. That is a very simplest approach, and which will lead to n square time complexity. So that we are not going to discuss here. That I have already discussed in the previous video. So we have to just make a quick change there, that for counting the number of subarrays, we will just keep a count for that, and the time complexity will be big O of n square. But the better approach for solving this particular problem will be the hashing prefix plus hashing approach. Again, we cannot use the sliding window approach here, because we know that if the input constraints will be having the negative values, like in this particular example, negative values were there, then sliding window approach will be failed. So we will be better using the prefix sum plus the hashing approach, which is the optimal one. Okay. So now this prefix plus hashing approach also I have explained, but just giving a brief that how we will be using it to solve this problem. Let's get into some detail. So this is the simple visual which I have taken in my previous problem. This is the, let's say, input array we are given with, and we do not want to take the or compute the sum again and again. We just be going from 0 to till the end index and having the cumulative sum at every index. Now at a particular index, if we are having cumulative sum or a prefix sum, we say, so I'm having all the possibilities of the subarrays which will be ending at this particular current index. For example, if right now I am at this fourth index. So from 0 to 4, I am having the subarray from 1 to 4, then 2 to 4, 3 to 4, and then 4. So all the possible subarrays I am having. So I am having the control over all these subarrays, from which I can find if any subarray is having the sum k or not. I cannot go beyond this particular j index. Now I'm just assuming for a while that if I want the sum k, and if any of the subarrays will be giving the sum k, then just assuming that this subarray will be giving the sum key. So I have just assumed it. Now if it is going to give the sum key, then for sure, because from 0 to till this current index j is the prefix sum, and this particular subarray is giving the sum key, then for sure this prefix sum minus k will be the sum till at this particular index I. Okay, and now if I say it in the reverse way, then if at this particular current index I am having a prefix sum, and if I try to find any prefix sum minus k which has been encountered earlier at some particular index, then for sure if that was encountered at I index, then from I plus 1 till this j index will be the subarray which is giving the sum key. So that is the intuition behind it. But what change we have to do so that we can solve this problem, like counting the number of subarrays? So how we can count those subarrays? Now right now we can see here that if the at this current index, if we are having this prefix sum, and I am saying that if I have encountered prefix sum minus k earlier, then for sure one subarray will be formed here from that I plus 1 till this j index. But what if this particular prefix sum minus k was encountered two times? Let's say, let me just remove this particular thing, and let me remove this particular subarray. And I am just saying that if this is the prefix sum right now at this index, and I have, let's say, I have encountered this prefix sum minus k at this 0 index. So let's just say this index as I1, and one. So what I will say from here, that I1 means from this 1 index till this 4 index is one subarray which is giving me the sum key. So let me just mark it here. This is the subarray I have got. Now let's suppose this particular prefix sum was encountered one more time. Let's say at this one index. So let me just give it I2. So this is I2 index where prefix sum minus k was encountered. Therefore, from this I2 plus 1 means from this second index till this fourth index is the another subarray I got. Okay, I can just mark this another subarray in this way. So what I can see from here, if this particular prefix sum minus key was encountered two times, then two subarrays will be formed, which will be ending at this particular current index. Okay, this is the whole intuition behind counting the number of subarrays. So now the problem is not about counting the number of subarrays with the sum key. The problem is boiled down to a basic problem, that count that how many number of times this particular prefix sum minus k was encountered earlier. The number of times it was encountered earlier, that number of subarrays will be formed, which will be ending at this particular index j. So this is the whole intuition behind it. And let's just go into the input or the example which we have taken, and let's have a dry run, simple to understand it. Okay, so this is the example I have taken in order to perform a dry run. And now we know that we will have to store these prefix sums whatever we are getting at the particular index, and also that how many number of times that prefix sum is coming, that also we will have to store. So for that we will need a particular data structure that we will be using. So let's take a unordered map here in order to store this. This is the unordered map. Let me just give it a name by the name frequency, because we will be storing the frequency of the prefix sums here. Now let me just maintain the prefix sum. Okay, in this we will be having the prefix sum, and one more variable I will be maintaining, that is for count, so that I can count the number of subarrays. Now let's just start from the zero index. This is the I which is pointing at zero index. Now firstly 1 will be added inside the prefix sum, so 1 will be added, it will become 1. And now we will be checking inside the map for prefix sum minus k, that means 1 minus 3, that is minus 2. So minus 2 have we encountered inside the map? No, we have not yet encountered minus 2. So therefore we have to do nothing here and just keep this prefix sum, that is 1, that how many number of times it came, it has came one time as of now. So I have just inserted inside the map. Now let's move further, and this I will be moving ahead at one index, and now it will be seeing 2. Okay, 2 is here, so this prefix sum will now become 3, and it will say, okay, now I have to check for 3 minus 3. Prefix sum minus k, 3 minus 3 is 0. So have we encountered 0 inside the map? So no, we have not encountered 0 yet. So now this is the same case which we have seen in the previous problem, that if any of the valid subarray is there, which is just starting from the 0th index, then we will have to check for 0 for sure inside the map. That can be in any case, like based on the requirements. As in the previous case we were finding for the longest subarray, so we will have to check for index. Since we are counting the subarray, so we will have to make a count of it. Okay, so in this we are seeing for prefix sum minus k, that is 3 minus 3, 0 is not encountered inside the map earlier. So what we have to do is, we have seen in the previous problem also that initially this prefix sum was 0. Okay. This was the prefix sum initially, and that was 0 when we have not yet started with the taking the sum, the cumulative sum. And also when we have not started with the 0 index, so we can say it was at minus 1 index at that time. So it is very logical to say that if this 3 minus 3 we have to find that 0, have we encountered 0 earlier? So yes, we have encountered 0 earlier when it was prefix sum as 0, when we have not started taking the sum, and also it was at minus 1 index. So here we will not say minus 1 index, we will say it was encountered once. Okay, that because we are checking for frequency in this problem. So we will say that prefix sum 0 was encountered one time when we have not started with the uh, taking the cumulative sum. So that we will have to also insert inside the map with the prefix sum and also of its count. So initially prefix sum was 0 and it was encountered once. Okay, so this we have inserted inside the map, and now when we check the 3 minus 3 0 is existing inside the map, so yes, it exists with the occurrence of 1. And now because it exists, so what we have to do here is that if you check for any prefix sum minus k earlier in the map that you have encountered, and now you have now you know that yes, if 0 was encountered once, then one subarray will be there which is having the sum k. Now to count it, in order to increment inside the count, what we will do, see the number of times that particular prefix sum occurred, prefix sum minus k occurred, that number of subarrays will be formed. So if this was occurred once, then you will be adding this particular value, this second value, second parameter inside the count, because it is representing the number of times this prefix sum occurred in the past. Okay, and that we have just seen in the visual. So this particular value will be added inside the count in order to count the number of subarrays. Okay, so what number is there? This is 1. So in this count 1 will be added, so count will become 1 as of now, and we have seen this 1 to 2. This is one subarray we have encountered so far. Now we have seen this prefix sum as 3 as of now, so we will also have to add this particular prefix sum inside the map along with the count. So it has been encountered 1 till now. Now I will be moved ahead and it will see 3. Okay, this is 3, so let's just take this 3, add it inside the prefix sum, so it will now become 6. Okay, now we will again check for prefix sum minus k. It means 6 minus 3. Has 3 been encountered in the map earlier? Yes, 3 has been encountered, and that was one time. We are now at this current index, and we have seen 3 earlier, that was encountered once. So therefore the one subarray will be formed, which is giving the sum 3. Okay, means we have encountered this particular 3, we can see here. Okay, this is the 3 which was given by this subarray. So therefore this particular subarray will be giving the sum k, and because it was one time, so therefore one subarray will be formed by this particular prefix sum minus k, because it was encountered once, so one subarray will be formed for sum k. This one will be now added inside this count, and it will now become 2. Till now we have seen 2 subarrays with the sum 3. One was this subarray and one was this subarray. Now the prefix sum 6 came, so we will also be adding this inside the map. So till how many times this particular 6 came? One time. So we'll be adding it one time. Now let's move this I ahead. So now it became -2. When it became -2, added inside this prefix sum, so it will now become 4. And now we will be checking for 4 minus 3. Have we encountered this 4 minus 3? 1. Have we encountered 1 inside the map earlier? Yes, we have encountered. We have encountered this particular 1 for one time in the past, and that we can see from the array, this 1. And from this particular 1 means from this index, then from +1, 1 2 3, this 2 and 2 will get cancelled when it is sum up, and this 3 will be remaining. So this particular subarray is also giving the sum of, so therefore this particular one subarray is also again formed, because this 1 was available once. Okay, so therefore this particular 1 will be added inside this. The count will now become 3. 3 subarrays has been found so far with the sum 3. Okay, so this is the prefix sum 4 which we have seen, and now it will be added inside the map, so it will be for one time. This, and now I will be moving ahead, and it will now see 2. So 2 is there, so again it will check for it will again sum up, so it will now again become 6. Okay, so now the prefix sum is 6, and now it will be again checking for 6 minus 3, that is 3. So 3 has been encountered once in this case. So we can see here that till this particular point, this was the prefix sum which was encountered as 3, and it was counted only for once. So therefore this one will again be added, because we have seen till here 3, and now after this, from this 2 to 4th index, 2 and 2 again cancels out and only becomes 3. So the sum again becomes 3. The count will be again increased by 1. Okay, and now it will become 4. So the 4 subarrays we have seen so far with the sum k. Now also we will have to add this particular prefix sum inside the map. So the map only stores for the unique keys. Unique key is 6. Only the frequency will be increased for it. So this particular prefix sum is having already the 6 was inserted with the 1 count. Now it will be again increased with the count 2. So we have seen 6 2 times. 1 is still here, and 1 till this particular index. This number of times we have seen 6. And now this I will be moved ahead, and it will be 1. Okay, now 1 is there, therefore it will be added inside the prefix sum, so it will now 7. Okay, so 7 minus 3 4. Has the 4 been occurred in the map earlier? So yes, 4 has been occurred once, where till this particular third index, like 3 plus 2 5 1 6 and minus 2 4. So that particular prefix sum was encountered here at third index. That was at one time, so therefore because it was at one time, so again this particular subarray is going to give the sum k, and because it was occurred one time, so this particular count will be incremented by 1 and goes to 5. And yes, again this particular prefix sum now became 7, so it will now be updated with the one count, that 7 particular, that the sum 7 was occurred one time. Now again it is inserted inside the map, and then I will be moved ahead. So now the array is completed, therefore we will have to stop here itself. Now we can see here inside the count, the number 5 is updated, and this particular 5 is the number of subarrays which are having the sum k. So this is all about this particular approach, and let's get to the implementation part, that how we can code it. This is the function which we are going to write, int n equal to, first we are going to have the size of this num, so n equal to this nums dot size. And after having the size, what we will have to do is we will have to use the unordered map here. So let me just write unordered map, and we will have to take the two parameters, one parameter for having the prefix sum, and another one is for taking the frequency count of that particular prefix sum. And let me just name it by frequency. And now this is the unordered map. What one thing we have seen is that if any of the valid subarrays are there which are starting from the 0th index, And for that we will have to just insert this frequency of 0 for 1. So means the virtual prefix sum was 0 for once initially when we have not started with taking the cumulative sum. For that we will have to take this frequency of 0, and then we will have to start it with the frequency 1. Now let me just take the prefix sum, and let me just initialize it with 0 of now, and also I will be taking the count variable which will be initialized to 0. Now I have taken the count variable which is initialized to 0, and now I will be going for a loop for int I equal to 0, I less than n, and I plus plus. And now inside this particular loop, firstly I will be taking the prefix sum. So just adding the values inside this prefix sum. So prefix sum equal to prefix sum of nums, prefix sum plus nums of I. And after taking this prefix sum, what we have to do is we just have to check inside the map that how many number of times the prefix sum minus k occurred. That will be with the help of condition if inside this map, and using the find function we will be checking for prefix sum minus k inside the map that is not equal to frequency dot end. And what does it says that if I have found a particular prefix sum minus k earlier, uh, it means if it does exist inside the map, and if it exists then just have the frequency of it and add it inside the count variable. So this count plus equal to count plus, in this map of whatever the second parameter will be there, it will be coming with the help of this frequency of prefix sum minus k. This is going to give us that particular frequency, the number of times that particular prefix sum minus k occurred, and that will be inside the count. And once it is added, we will also have to keep this particular prefix sum inside the map as well. So frequency of prefix sum, and that will be we will be incrementing once whenever it is taken. So at any point of time, means at any particular index we are having a prefix sum, we will be adding inside the map with one frequency like +1. And if next time if the same prefix sum comes, then we will also be adding obviously because the unordered map is having the unique keys, so it will just increment that count of the frequency if the same repeated prefix sum occurred. So that we will be doing. Obviously we will be incrementing the prefix sum if any repeated prefix sum also comes. So for that also we will be incrementing the frequency, because in this problem we need the number of subarrays which are giving the sum key. The previous problem, that was the longest, means the length of the longest subarray. That case we will not be updating with the latest index, because that will not be giving the longest subarray. But in this, because we have to count the number of subarrays, so we must know that how many number of times that prefix sum minus k occurred earlier. So that will only be possible when if we just increment this count for that particular frequency of the repeated sum, then only we will get the correct value, the correct number of the subarrays which are giving that sum key. And at the end we will just return the count for it, the count, and when we return it, will just give us the number of subarrays which are giving the sum key. Here 5 is the output we have seen in the diagram. 5 is going to come here as a result. 5 subarrays in the given input array with sum 3. One subarray is this 1 to 2, second is only 3, and third subarray is this -2, this 2 3 -2, and another subarray is 3 -2 2, and another subarray is this 2 1. So these are the 5 subarrays in the given input array with the sum 3. Okay, so now checking for the time complexity and the space complexity. In this particular approach, we can see here the loop is used, the one loop is used running for n times. So for n number of elements, every element, because we are using unordered map, so every element will be taking the constant operation in order to like find like for the find operation or any search operation or any insertion, that is just going to take the constant operation. So because of which the average time complexity is big O of n. Just in case if the collisions occur, then it might goes to the big O of n square in the worst case. That is very rare. Okay, and then talking about the space complexity, so again we are using the unordered map, so the space complexity again big O of n, that is the linear space required. Here we cannot use the sliding window because the negative numbers can be there in the input constraints. So because of the negative values, the sliding window fails there. This is the optimal solution you can think of in order to solve this particular problem. It's all about this problem, and for the more variants of this problem I will be coming with the another videos.